In this video, I will explain voltage to current converter. Voltage to current converter. Voltage to current converter. In a voltage to current converter, the output to load current is proportional to the input load voltage. In voltage to current converter, the output load current is proportional to the input voltage. That means IL is output load current is IL is proportional to input load voltage VA. These are the two configurations. Here VA is applied to inverting terminal of the top end minus VA is applied to non-inverting terminal of the top end. Here these are this node two currents. This is the IB current. This one is IB current. This one is IB current. According to connection of load, there is two types of VA connectors. There are two types of voltage to current converters. First one is floating type V to IL converter and V to I converter. In that floating type V to IL converter, the load resistance RL is not connected to ground. In this diagram, RL is there. Here RL is there. RL is not connected to ground. This is called as floating. This is called as a floating type V to IL converter. Second one is in ground type. V to IL converter. Second, we will explain later. Ground type V to IL converter. The RL is connected to ground. Here, floating type V to IL converter, voltage to load current converter. RL is not connected to ground. RL is not connected to ground. Analysis. This is the VA. The current coming from the VA is II. I is equal to IB plus IN. Consider op amp is an ideal one. IB is equal to 0. Therefore, IA is equal to IN. Here, this is the V1. This one is V2. V2 is connected 0 volts. According to virtual ground concept, V1 is also connected to 0 volts. That means this is connected to ground. Therefore, IA is equal to this one is VI. This one is VA. This one is RA. RA is connected to ground. This is also connected to ground. The current is IA. Therefore, apply KVL. Therefore, IA is equal to VA by RA. IA is equal to VA by RA. See that IA is equal to VA by RA. IA is nothing but IB is equal to 0. IA is equal to IL. Therefore, IL is equal to VA by RA. Therefore, load current, IL is the load current. IL is the load current is directly proportional to directly proportional to VA input voltage. That is the V2I converter. Due to this input voltage VA, the load current is produced. This is called as a V2I converter. Voltage to current converter. This is the floating type. Floating type means the RL is not connected to ground. Coming to this one, second one, here VA is applied to an inverting terminal of an op-amp. Here, according to virtual ground concept, here V1, here V2, here V1 is equal to VA. Whatever voltage available here, that voltage is available here. Again, IL is equal to IA plus IB. This is IB current. This is IB current. IB is equal to 0. IL is equal to IA. The voltage available at this point is VA with respect to ground. Therefore, VA is available here. VA is available. Therefore, IA is equal to VA by R. VA is equal to VA by R1. Here R1 not. This one is R1. Because this resistance is R. Again, load current IA is directly proportional to input voltage VA. Constant proportionality factor is 1 by R. See the voltage to current. Voltage obtained, current is obtained due to input voltage. Suppose the load is connected to capacitor. Suppose if the load is a capacitor, the load is a capacitor, it will charge and discharge. It will charge and discharge at a constant rate. Instead of this load resistance RL, we use capacitor. Therefore, if the load is a capacitor, it will charge and discharge at a constant rate. Hence, such converter circuit are used to generate sawtooth waveform, and triangle generator. Triangular waveform generator. Triangular waveform. This is also called as a transconductance because the load current is directly proportional to input voltage VI. This is also called as a transconductance and it is also called as a voltage controlled current source. Current is obtained due to input voltage VI. That is the That is called as voltage control current source. What are the applications? Some important applications are there. Next one, voltage to. This one is the voltage to current converter. Current converter with ground. With this is the voltage to current converter with ground load. In previous case, floating node. Floating node means the load resistance RL is not connected to ground. Here, the load resistance RL is connected to ground. This is the type of non-inverting amplifier configuration. Non-inverting amplifier. Non-inverting amplifier configuration. Why? Because that the signal source VI is connected to plus non-inverting terminal of the op amp. This one is RF. This one is RB. We know that the gain of the non-inverting amplifier is AF is equal to 1 plus RF by R1. That is equal to 1 plus RF is R. R1 is also R. 1 plus that is equal to AF is equal to 1 plus 1. That is equal to 2. AF is equal to V naught by. We know that AF is equal to V naught by output voltage by not VI. Input voltage is V1 because this V1 is applied to non-inverting terminal of the op amp. V naught by V1 is equal to 2. Therefore, V naught is equal to 2V1. V naught is equal to 2V1. This is the voltage to current converter with ground load. This is the ground load, and that load resistance RL is connected to ground. Coming to this point here, at this node A, apply KCL. Apply KCL at node A. Therefore, I1 is equal to IN this is I1 plus I2. These two currents are entered into is equal to IN. This is the actual circuit. Voltage to current converter, that is ground load. Ground type. Ground type means the load resistance RL is connected to ground. Apply KCL at node A. At node A, I1 and I2 currents are entered into that node. IL current is away from the node. The I1 is VI minus V1 by R. I2 is equal to V naught minus V1 by R. Therefore, IL is equal to V1 by R. V1 by R. Or let it be put to it will be higher. Our aim is the load current is directly proportional to input voltage VA. Prove prove this. VI minus V1 plus V0 minus V1 is equal to IL into R. Here V1 VI plus V0 minus 2V1 is equal to minus 2V1 is equal to IL into R. 2V1 is equal to VI plus V0 minus IL into R. Therefore, V1 is equal to VA plus V0 minus IL into R by 2. But V0 is equal to V1. V0 is equal to V1. Therefore, 2V1 is equal to 2V1. Consider this one. 2V1 is equal to VA plus V0 minus IL into R. Need not use this expression. Not use this expression. Directly use this one. But V0 is equal to 2V1. V0 is equal, we know that V0 is equal to 2V1. Substitute V0 here. V0 is equal to VA plus V0 minus IL into R. Therefore, IR is equal to VA. IL is equal to load current IL is equal to VI by R. Therefore, IL is directly proportional to VA. This is the voltage to the load current, voltage to current converter. Voltage to current converter. Input to the amplifier is VI and output current is IL. This one is VA and this one is IL. Applications of that voltage to current converter is in the load type, not floating type applications. Low voltage AC meter here. Low voltage AC voltmeter. Low voltage DC voltmeter. Diode tester and match finder.